Hi everybody, welcome back. The purpose of this video is to help you with the rational functions assignment that was posted on Monday, April 27th. In this video, we're going to go through these two problems, and we're not going to graph them, but we're supposed to figure out the domain, X-intercept, vertical asymptotes, holes, horizontal asymptote, and Y-intercept of each function. And we're going to go ahead and get started. The domain, we have to consider every possible value of x that we can plug into these functions, and we are limited by the fact that we're not allowed to divide by 0. So the first step we want to do is factor the numerator and the denominator and figure out the values that would equate the denominator to 0. I can factor out the greatest common divisor of the numerator is 2x. And 2x multiplied by what is 2x squared, x. 2x multiplied by what is equal to 4x, that number would be 2. And in the numerator, this is a quadratic trinomial, and we could factor that as what times what is x squared? Well, x times x. Now we need to find two numbers that have a product equal to 12 and a sum equal to -8. And when you're factoring, you can actually just divide the number 12 by every number up to the square root of 12, which is 3 point something, and you will have ran into every single factor pair if you do that. And you only have to check it up to 3 because the square root of 12 is 3 point something. So every factor pair of 12 is listed on my calculator right now. 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. Which pair adds up to 8, 2, and 6? Now, since it adds up to -8, we're going to have to make both of those negative. Now, if you FOIL this, you could verify that it does, in fact, equal that 8 x squared minus 8x plus 12. All right, so we factored our rational function. Now, what values would equate the denominator to 0? If I plugged in a 2 for x here, or if I plugged in a 6 for x here, that would equate both of them to 0. So we're going to say the domain is all real numbers such that x is not allowed to equal 2 and x is not allowed to equal 6. Or you could just literally write that out. You could say all real numbers with the exception of 2 and 6. Alrighty, so let's take a look at the X-intercepts. This was a while back. It was all the way back in November that we did this unit on rational functions. But the X-intercepts occur at zeros of the numerator that are not also zeros of the denominator. So we have a 0 at 0. If we plug the 0 in for x, it would equate the numerator to 0. So that's one of our X-intercepts, that's 0. And another X-intercept would be at -2. If we plugged a -2 in for x there, it would equate that parentheses to 0. So our two X-intercepts are 0 and -2. Our vertical asymptotes occur at zeros of the denominator that are not also zeros of the numerator. And that would be both at 2 and 6. Those are our vertical asymptotes. 2 and 6. And if you want, you could list the vertical asymptotes as vertical lines, x equals 2 and x equals 6. The holes occur at points of discontinuity that appear in both the numerator and denominator. There are no holes in this particular rational function. There are no zeros that repeat in both the numerator and the denominator. They're all unique zeros. So there are no holes in this one. I'm just going to write not applicable. Horizontal asymptote. The rule for horizontal asymptotes is you have to look at the degree of the numerator and the denominator. There are three situations that could occur. The degree of the numerator could be less than that of the denominator. It could be greater than that of the denominator, or the two can be equal. In this one, we have that they're equal. When the degrees are equal, you actually have to take the leading coefficient of each, the numerator and the denominator, or actually the leading coefficient of the highest degree term, and you have to divide them, and that's where you have a horizontal asymptote. So we're going to be doing 2 divided by 1, and we have a horizontal asymptote at y equals 2. The y-intercept is where the line crosses the y-axis, and that occurs when x is equal to 0. So to determine the y-intercept, we're just going to take our function and we're going to replace x with 0, and that'll give us where the function crosses the y-axis. Plug in 0 here. All right, so the numerator is going to equal 0. 0 squared is 0, times 2 is 0, plus 4 times 0 is 0. In the denominator, 0 squared is 0, 8 times 0 is 0, 0 minus 0 is 0, plus 12 is 12. So we have a horizontal asymptote. I'm sorry, we already did that. We have a y-intercept at 0. So this is going to cross the origin. Okay, so if you want to see a quick peek at the graph of this, it's kind of weird looking, but you can verify that all of this information is correct. Here's a picture of the graph. I'm going to turn this green one on here. We have that it crosses the origin. We just talked about that. That's the y-intercept at 0. We have our 2 vertical asymptotes, and they are located at 2 and 6, so at positive 2 and 6. And we have our horizontal asymptote located at y is equal to 2. You can see that if you continue this, it approaches this limit here at where it never really crosses this line. You have a horizontal asymptote where this function approaches the number 2 on both the right side and the left side. And that's about it. All right, let's go on to our next problem. We have to figure out all of this information: domain, x-intercepts, vertical asymptotes, holes, etc. And to do that, the best way to get started is just to factor the original problem. So let's factor the numerator. I'm going to factor out first. They are all divisible by the number 2, and they each also share an x in common, and we can't factor out any more than what appears in the term with the least amount of x's, and we only have 1 x here. So the most I can factor out of all 3 of these terms is 2x. All right, 2x goes into 2x cubed how many times? X squared. Because 2x times x squared is 2x cubed. How many times does 2x go into negative 6x squared? Negative 3x, because if you multiply them, you get negative 6x squared. Negative 8x divided by 2x is negative 4. All right, and this can be factored further, actually. Our x squared minus 3x minus 4. What times what gives us x squared? X times x. Now we need 2 numbers that have a product of negative 4 and a sum of negative 3. Well, 1 goes into 4 times, and 1 minus 4 is equal to negative 3. So this is going to be a positive 1 and a negative 4. They multiply to negative 4 and add up to negative 3. Our denominator, that is a classic difference of 2 squares. X times x is x squared, and if we make a negative 1 and a positive 1, we'll end up with a negative 1 there. And the middle terms will cancel out, and that's why there's no x term in the middle there. All right, so our rational function is completely factored, both the numerator and the denominator, we'd start thinking about where the domain restrictions are, what the x-intercepts, vertical asymptotes, and holes are. Remember, the domain can really be anything except in a rational function you cannot divide by 0. So what numbers would equate the denominator to 0? It would be 1 and -1. So all real numbers such that x is not allowed to equal -1 and x is not allowed to equal +1. So you could literally just write that out. All real numbers except -1 and +1. That's our domain. Our x-intercepts. The x-intercepts are the zeros of the numerator that are not zeros of the denominator. So our x-intercepts here are, well, you can see that if you replaced 0 here, it would equate that whole numerator to 0. So one of our x-intercepts is 0. Another number that would equate the numerator to 0 is -1. That would turn this into a 0. And finally, if you put a 4 in there, that would also equate the numerator to 0. So our x-intercepts are 0, -1, and +4. Our vertical asymptotes. The vertical asymptotes are zeros of the numerator that are not zeros of the denominator. Actually, one of these x-intercepts appears in the denominator, so it's our -1 is actually not an x-intercept, but instead it's a whole. Alright, so our vertical asymptotes are zeros of the denominator that do not appear as zeros in the numerator, and that would be just one of them, the number 1. 1 minus 1 is 0, and 1 does not equate the numerator to 0. Holes. Holes are zeros of both the numerator and the denominator. So they're points of discontinuity that would equate both the numerator and the denominator to 0. So if we put in a -1 here, it would make the numerator equal 0, and if we put a -1 in the denominator, it would make it equal 0. And that's why there's a hole at -1. Horizontal asymptote. The rule for horizontal asymptotes, when the degree of the numerator is greater than that of the denominator, is that there is no horizontal asymptote. The y-intercept, finally. We figure out where the rational function crosses the y-axis by replacing x with 0. Just going to replace my x with a 0. Alright, 0 cubed is 0, 0 squared is 0, 0 times 2 is 0, 0 times 6 is 0, 0 times 8 is 0, 0 minus 0 minus 0 is equal to 0. So the numerator equals 0. The denominator equals 0 squared minus 1. That's equal to -1. And 0 divided by anything is 0. So our y-intercept, again, is 0, which means that this rational function crosses at the origin. Let's go ahead and turn that function on. It's this blue one here. So you could see it does, in fact, cross at the origin. It also crosses at our other x-intercept that we said. Our other x-intercept was +4. And you could see that that's +4 right here. These are counting by 2 on the x-axis. And there is a vertical asymptote. There's a vertical asymptote at +1. You can see that right here, that little vertical line. And there is no horizontal asymptotes in this one. Alright, so hopefully that will help you get started on the assignment that was posted on Monday. If you have any questions, please reach out to me via email. Also, we're going to have a little video meeting on Tuesday. Please check Google Classroom for the code for that meeting. It's at 2 o'clock. And I look forward to seeing you. I miss all you guys. Thank you for watching.